Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. So in today's video session, I am going to discuss about the torque slip characteristics of three-phase induction motor. Okay, so here already we know the torque. So torque equation is 3 divided by 2 pi ns into SE2 square R2 by R2 square plus SX2 whole square. And slip S is equal to ns minus nr divided by ns into 100, right? So torque and slip equation, right? Now we have to discuss about the torque slip characteristics of three-phase induction motor here. Okay, so here first we are going to write the torque equation first. So the torque equation is T equal to 3 divided by 2 pi ns into SE2 square R2 divided by R2 square plus S into X2 whole square. Right, here is the torque equation. So this torque equation I am writing as T equal to some constant K into SE2 square R2 divided by R2 square plus SX2 whole square. Again I am writing like this, T directly proportional to SE2 square R2 by R2 square plus SX2 whole square. Okay, so here the torque is directly proportional to SE2 square R2 divided by R2 square plus SX2 whole square. So in this torque slip characteristics, we are having the two cases. For the case 1, lower values of slip, case 2, higher values of slip. So I am taking the first case 1. For the case 1, lower values of slip. So here for the lower values of slip, we are having the R2 values are very low, right? Means we have to eliminate this R2, we have to eliminate the R2 term here. So means T directly proportional to S into E2 square divided by S into X2 whole square. So now here in this equation I am taking this term as a constant here. Then we'll get torque directly proportional to S. If torque is directly proportional to S means it is a linear. Okay, so here I will draw the graph here. So torque and slip. So here for the case 1 we are getting torque directly proportional to S means it is a linear. So linear means it is starting from the origin. So it is starting from the origin. So this is torque directly proportional to S for the case 1. And for the case 2, higher values of slip. So higher values of slip. So in that case, T directly proportional to, so we have to remove the S values here, R2 values here. So that is S into E2 square R2 divided by S into X2 whole square. So this equation I am writing like this, T directly proportional to S E2 square R2 divided by S square X2 square. So in this equation, this E2 square X2 square R2 is constant here. So eliminate this term. Then we'll get T directly proportional to S by S square. So S, 1S get cancelled. So T directly proportional to 1 by S. So if T directly proportional to 1 by S means it is a hyperbola. Okay. So hyperbola means we will get the graph like this. Right. So up to here we are having the slip values. So slip values are in between 0 to 1 only. Right. So this is T directly proportional to 1 by S. So here we are having the maximum torque, that is T max. We are having the maximum torque. At maximum torque we are having the maximum slip. So this maximum slip is defined as, it is the ratio of the rotor resistance and rotor reactance. We can call it as a maximum slip. Now initially if slip S is equal to 0, what is the speed of the rotor or what is the speed of the induction motor? So already we know the NR equal to NS into 1 minus S is the equation. Rotor speed is NS into 1 minus S. If S is equal to 0, so NR equal to NS into 1 minus S. If S is equal to 0, so we'll get 1. So rotor speed is same as synchronous speed. If S is equal to 0, rotor speed is same as synchronous speed. Suppose if S is equal to 1, so what about the rotor speed? So here slip values are in between 0 to 1 only. Okay. So here if S is equal to 1, what about the rotor speed? So here NR equal to NS into 1 minus 1. So NR is equal to NS into 1 minus 1 means 0. If S is equal to 1, we'll get rotor speed is 0. So that's why always slip values are in between below 1 only. That is, we have to say that is 0 to 1 or 1 below only. Okay. So here the slip values are in between 0 to 1 or 0.9. Okay. So here is the torque slip characteristics of 3-phase induction motor. For the case 1, we are getting T directly proportional to S, and for case 2, T directly proportional to 1 by S. So it is a linear for the case 1, and for the case 2 it is a hyperbola, and this is the torque slip characteristics. So torque slip characteristics of 3-phase induction motor. Okay. So thank you one and all.